In this video, we will be talking about this is a walkthrough of the exercises 6.1, or let me clarify. Uh, in the PDF, it's called exercises 6.1, but in the Philippine edition, it's called 2.1. Just so I can clarify the possible confusion to those who might use the Philippine edition book and those who will use the PDF. I'm not sure though in the actual American copy if it's also called exercises 6.1. What I'm very sure of is that 6.1 is the PDF version. So the lesson or the lesson is all about the fundamental identities and the families of identities. So you might want to take note of this. Let's start with number 11. Wait. Let's have a brief discussion about these identities. So for reciprocal, we all know that sine, its inverse is cosecant. So this is well said. For cosine, that also goes with cosine. The inverse of cosine is secant. The inverse of tangent is cotangent. For ratio identities, just know that tangent is sine over cosine. Tangent is secant over cosecant. You can see the relationship between the two. Cotangent is cosine over sine. Because tangent is inverses with cotangent, it's pretty obvious now that you could say the numerator of tangent is sine, the denominator of cotangent is cosine. So I hope you can ponder in regards to that. The Pythagorean identities, whenever you see sine, the sum of sine raised to 2 theta and cos raised to 2 theta, it's basically 1. You can find this really useful, especially in complex expressions. You can make it simplified with the help of this identity. Of course, you also have the tangent raised to 2 theta plus 1 is equal to secant raised to 2 theta. That also goes with this. 1 plus cotangent raised to 2 theta is equal to cosecant raised to 2 theta. You might want to take note of these. The rest is pretty easy to memorize soon, except this. But these three are pretty difficult to memorize in my opinion. You might want to take note of them. So yeah, that's it. I won't be discussing this anymore. We didn't really use much of it in our class. So yeah, I think these matter a lot more. Or at least they're more relevant to what we're supposed to do in this exercise. So this is exercise 6.1. Let's start. For number 11, by the way, I'll just read the instructions briefly. Verify the equation if verify the equation is an identity using multiplication and fundamental identities. So for number 11, we have sine x cotangent x is equal to cosine x. So just write sine x. Cotangent can be equal to cosine x over sine x. So what we want right now is that we want to cancel like terms, and as you can see, as simple as that, you found your final answer. You have now verified that these the two parties that compose the equation itself are equal to each other. So that's it. Verify the equation. Right. For number 12, by the way, multiplication, part of it is cancelling. So expect a lot of cancelling if you want to verify. Of course, also involving fundamental identities, the ones here. Please take a screenshot, or at least if you have notes on this, then very good. You're gonna make use of it. I'm not sure though if your teacher will allow you to have a copy of these fundamental identities, but in our exam, our teacher allowed us. Unfortunately, if some teachers don't allow, you're gonna have to memorize. But that already gives you an advantage. Not many students are able to memorize this, so take it to your advantage. Okay, for number 12. So cosine x times tangent. Tangent is, in other words, sine x over cosine x, which is equal to sine x. So cancel like terms and done. We just verified number 12. For number 13, secant raised to 2x, that could be, in other words, secant's inverse is cosine. And you can convert cotangent into something like this. If you compare this one with the identities, you can see why they're not exactly the same, but the only difference is the square, the exponent of 2. I hope you can ponder on that as well. Anyways, let's proceed. You don't really have to copy this part anymore, or the part that you're not trying to verify. Just choose the side that's a lot more complicated and work on it. So with this, 1 over sine raised to 2x, we know that the inverse of sine x is cosecant, so we verified it. These two are the same. Right? Let's move to number 14. Cosecant, that could be converted as sine raised to 2x. And tangent could be converted as like this. So, cancel like terms. 1 over cosine raised to 2x is equal to secant raised to 2x. 1 over cosine could be also called secant raised to 2x. So there. That's it. Let's move to number 15. Cosine x over 1 times secant. Secant is basically 1 over cosine. And we have here something like this. Alright. Let's see. Actually, wait. Remove this. Let's start again. We have distribute cosine to the two other terms. Sometimes you just gotta have to improvise. So right now we know that cosecant and cosine and secant are inverses with each other. So let's cancel. So we're left with 1 minus cosine raised to 2x, which is equal to sine raised to 2x. Verified. If you're wondering where this identity came from, it's basically derived from this one. So basically, basic algebraic manipulation, sine raised to 2 theta is equal to 1 minus cosine raised to 2 theta. This is a derivation from this one. Of course, consequently, you could say that cosine raised to 2 theta is equal to 1 minus sine raised to 2 theta. Basic algebra. Alright, let's move to number 16. For number 16, again, distribute. I think that's the best first step to do. So tan x cotangent x plus tan raised to 2x is equal to secant raised to 2x. Tangent could be written as sine x over cos x times cotangent. Cotangent is cos x over sine x. So they cancel each other. Just copy the rest. I won't write this anymore. So this is 1 plus tan raised to 2x. What is equivalent to 1 plus tan raised to 2x? Let's see. 1 plus tan raised to 2x. Secant raised to 2x. Are they the same? Yes. Therefore, this is verified. Alright, let's move to number 17. Sine x times cosecant x minus sine raised to 2x is equal to cosine raised to 2x. So sine x, the inverse of cosecant is sine, so we get something like this. Cancel like terms. 1 minus sine raised to 2x is equal to what? Cosine raised to 2x. They're basically identities of each other. So that's it. We're done with number 17. Let's move on to number 18. Cotangent, again, distributive property. Cot x tan x plus cot raised to 2x is equal to cosecant raised to 2x. So we know that the inverse of tangent is cotangent. So we can write something like this. Cancel. I just copy everything over here. So we get 1 plus cotangent raised to 2x, which is equal to cosecant raised to 2x. Let's review the identities. So 1 plus cotangent is cosecant raised to 2. Well said. They're equal to each other. Number 18 is verified. For number 19, again, distributive property. Tan x cosecant x plus tan x cotangent x is equal to secant x plus 1. That's pretty long, but I won't get intimidated by it. Tan x, the inverse of cosecant is, let's make tangent as written in this form. We want to make sure that cosecant is in its inverse, which is sine x. Then for tangent times cotangent, cotangent's inverse is 1 over tangent. So I'm sorry about that. There's a lot of wind right now, but that won't stop me from teaching. 1 over cosine x plus 1 is equal to secant x plus 1. Cosine's inverse is secant x. Then plus 1. As you can see, they're the same with the right side. Therefore, this is verified. Right. Let's move to number 20. So, cotangent x secant x plus cotangent x tangent x. Secant's inverse is cosine. Inverse of tangent is 1 over cotangent. Okay. Cosine, I'm sorry about that. 1 over sine x could be written as that could be written as cosecant x, then you just add the plus 1. As you can see, I'm sorry. They're the same. Alright, I'm thinking if we could make a part 2. It's pretty long. Yeah. I'll give you a few minutes to digest what has been taught from numbers 11 to 19. We answered a total of, if I'm not wrong, 8 questions. So yeah. Finalize your notes, then we'll proceed shortly after. Okay. So from numbers 21 to 28, 29, 30. Okay. Number 21. I think the instructions are still the same. Verify the equation as is an identity using factoring and fundamental identities. Tangent is, it could be written as this, and cosecant could be written as this. So cancel. 1 over cosine is, cosine raised to 2x is secant raised to 2x, then minus, oh wait, just keep it written as this and subtract it with this one. So for a while, my foot is aching. Please skip this part. I might take a few more seconds. My foot aches. Ouch. Crap. Oh my goodness. Alright, let's proceed. Where are we? Okay, numbers 21. Actually, let's not do this. One over cosine could be written as this. According to identities, this could be equal to 1 already. So this is the formula derived from this one. Right, let's move to number 22. Sine raised to 2x times cotangent raised to 2x. So and we have sine raised to 2x here. Okay, this is going to be pretty easy. We know that the sum of sine and cosine raised to 2 would always be equal to 1. That's it for number 22. Number 23, here we go. Sine, cosine. Okay. I think we could use factoring method in number 23. We have something like this. and equal to tan x. Cancel both sides. We have sine x over cos x. Obviously, sine x over cos sine x would already be equal to tangent x. I won't be speaking too much right now. I've already mentioned about what you're supposed to do in the first place. Uh, it might be pretty redundant if I keep saying it again and again. But yeah, just watch what I'm doing. I'll be saying a few more phrases from time to time. That's going to be it. Cosine x over sine x, that's cotangent x. And in other words, for number 25, we factor something in the denominator part. So 1 over cosine x, the inverse is secant x. Let's move to number 26. We all know that the inverse of sine x is cosecant. So yes, verified. Number 26. Number 27. So sine x, because tangent is in the denominator, sine x over tangent x could be written like this. And so okay, that's number 27. Number 28, here we go. Cosine x divided by cotangent. Cotangent could be written, in other words, like this. And so you'll get something like this in the end. Okay, we're at number 29. We have to verify the equation is an identity using special products and fundamental identities. So for number 29, we just expand this one. Just like that, and really expand. Use the FOIL method. So right now, sine raised to 2x plus cosine raised to 2x could be written as 1, and we have something like this. And right now, I think we could divide both sides with cosine x. One over cosine x could be written as secant x, then plus 2 sine x. Same. They're verified. Okay, let's move on to number 30. 1 plus tan x, 1 plus tan x. Okay, this is going to be pretty challenging. 1 plus tan raised to 2x is basically secant raised to 2x. You have to be sharp in regards to that one. Right now, secant raised to 2x and secant x for a while. Okay. We get something like this. So 1 plus tangent raised to 2x, we get this numerator, and this numerator goes for here. Altogether, they both have the same denominator. So yeah. From that, say this will be cancelled. So we have secant x, then plus 2 over 1 times sine x over cosine x divided by 1 over cosine. And so just just duplicate everything there, eliminate the division sign, use reciprocation, cancel, and we get secant x plus 2 sine x. Aren't they the same? Oops. But I hope you do get the point. That's the answer for number 30. Let's move on to number 31. I'm planning to stop at number 34. Let's make a part 2 for exercises 1.3. I think this is 1.3. I'm sorry. This is 6.1 or 2.1. Okay, for number 31, apply the FOIL method. Basically, we get something like this. And so we get this. For number 32, we have secant raised to 2x, and we have minus 1. Somehow I made my solution and my answer key is pretty long, but right now I think this is another technique. Secant raised to 2x minus 1 is also equal to tangent raised to 2x. Let's see. So secant minus 1 tangent raised to 2 theta is equal to secant raised to 2 theta minus 1. Okay, this is a derivation from this formula. So yeah, that's it for number 32. Number 33. We all know that this is something that you have to take note again. Cosecant raised to 2x minus cotangent raised to 2x is equivalent to 1. It's pretty difficult, to be honest, but yeah, you have to take note of that. So yeah, that's for number 33. Number 34. Secant x minus tan x, or whether they're both raised to 2, they're still equal to 1. The inverse of cosecant is sine. So they're equal to each other. This is verified. Okay, that's it for this video. I'll be making a part 2. This is part 1. I hope you've learned something. Thanks for watching.